Okay, this video has to do with calculating an empirical formula. So when you get a problem and it gives you the grams, the thing is the empirical formula is the simplest whole number mole ratio. So it's the simplest whole number mole ratio. So what you got to do is change all your gram data into mole data and figure out the simplest ratio. So what I would do first is start off with 3.21 grams of sulfur. And then what I would do is I'd look up on the periodic table and find the molar mass of sulfur and change it to moles. So for every 1 mole of sulfur, you're going to have around 32.1 grams of sulfur. So that turns out to be equal to about 0.100. Okay, then you would do the same thing for fluorine. So 11.4 grams fluorine, and then you would go 1 mole fluorine, and then you would look up the molar mass of that, and it's roughly 19 grams of fluorine. And so you would do that, and it ends up being about 0.600 moles. All right, now to get the simplest whole number ratio, it has to be in moles. That's what we just did. We calculated these in moles. So what we're going to do is take the smallest number and divide it by itself. What that does is that always sets it to 1. And then we're going to take the bigger number and divide it by the small number. And 0.600 divided by 0.100 equals 6. So the simplest whole number mole ratio for SF6 is for every 1 mole of sulfur, you have 6 moles of fluorine. So this is the empirical formula, the simplest whole number ratio. Now, this problem gave you mass data. Sometimes you get a problem where they give you percent composition data. And so when you get a problem like this one, and they want you to get an empirical formula, and you're working with the percents, step number 1 is to assume 100 grams. And if you assume 100 grams, then you have 46.7 grams of nitrogen, if you assume 100 grams because it's 46.7%, and you have 53.3 grams of oxygen. Now, all you got to do is, just like the last problem, change them both to moles and find the simplest ratio. So for every 1 mole of nitrogen, it's roughly 14 grams of nitrogen. And if you do the math there, you end up getting about 3.30, something like that, moles. And if you do it for oxygen, 1 mole oxygen is 16 grams of oxygen. If you end up doing that one, you also get about 3.30 moles. And so take the smallest number and divide it by itself, where they're both the same number. And so basically they're going to be in a 1-to-1 ratio. So the simplest empirical formula then for this problem is N with 1 of those and 1 O, 1 oxygen. Okay, let's do another one here. A compound, this one it's giving you 3 percentages. So step number 1, you assume 100 grams. Okay, so by doing that, that gives you 55.3 grams of potassium, 14.6 grams phosphorus, and 30.1 grams of oxygen. Then you have to change each to moles. 1 mole potassium, that's roughly 39.1 grams is the molar mass of potassium. Well, let me calculate this here. This would be about 2.994 3 moles if you round it off a little bit. 14.6 grams phosphorus, so 1 mole phosphorus. You look up on the periodic table and you get the molar mass, it's 31 grams. And so if you do that, you get about 0.471 moles. And then if you do the same thing for the oxygen here, change it to moles. 1 mole oxygen, that's roughly 16 grams. You do the math and you get 1.88. Okay, now what you got to do is, this one's not quite as obvious as the last one. You got to divide the smallest number by itself, and that happens to equal 1. All right, then you take the next number and you divide it by the small number. So you're going to divide each of these by the small number. This one happens to equal, oh, you know what, I wrote this down wrong. This does not equal that. This equals 1.41. I got ahead of myself. So I'm going to take, because this times 1 divided by 39.1 is 1.41. So I'm going to take that divided by 0.471, and that roughly equals 3. And so I'm going to take 1.88, and I'm going to divide that by 0.471, and that's going to equal 4. Notice how I took the smallest moles, divided it by itself, that sets it to 1. Then I take the next ones and I divide them by the small one also. And so then I get this ratio. I get K3P1, which I'll just leave the 1 off, O4. K3P04. All right, there's one more type of problem that you need to know how to do, and it's where